Hello. In this demonstration, we want to really cover some of the very fundamentals of decision-making under uncertainty. And we'll do it try to make it realistic. I'd like you to play along. So consider that you have this opportunity and you can invest $20 and the return will be uncertain. In fact, the investment will not be returned. So it becomes what we call a sunk cost. Decision-making in general is only forward-looking. So what's behind us is only information to go forward. Decisions can't undo what the past has done, but we can do things differently going forward. So once it's a sunk cost, it really means after that, you should ignore it. Very hard to do in real life. We get attached. We have all kinds of sunk cost fallacies in our decision-making. But it becomes a sunk cost, and assume that once you commit, it's gone. Now, to simulate uncertainty, I'm going to use 4 playing cards. And I have them right here, and they are aces and kings. There are 2 aces and 2 kings. And what I will do is shuffle them, and after shuffling them, we'll put them down, and someone draws 2 cards, okay? And when those 2 cards are drawn, if they are 2 aces, that's a great outcome because you'll receive $60. You invested 20, you get 60. If it ends up being an ace and a king, it's still pretty good. You get $30. But if you have 2 kings, now it's kind of bad because not only are you out your initial investment, you have to pay an additional $18 and get nothing back. So the worst outcome is a total out-of-pocket of the $20 investment with another $18 that goes behind it to solve the mess that had been caused by the initial decision, okay? So think about that as a realistic investment opportunity. We can draw it up, and it's very clear when we use a decision tree, we use squares for decisions, and the investment is either $20 or not invest, and we use circles for uncertainties, and in this case, the uncertainties are resolved in 2 aces, we get plus $60, 2 ace and a king, or a king and an ace, the order doesn't matter, we get 30, and we get 2 kings, we have to pay this additional 18. So the decision tree makes it very clear. The only thing that's missing is, so what are the probabilities? How would we know the probabilities of this? Well, let's consider it. There are 4 possible outcomes, an ace and an ace and a king and an ace, and a king and a king. So what's the chance? Well, most people, like 80% or so, say it's 1 chance in 4 because they can't see a reason why any of those 4 would be more likely than any of the others, and therefore it feels like 1 in 4. And we can get that clearer by drawing what we call a probability tree. So the first card that we draw can either be an ace or a king, and it's equally likely. But once we draw an ace, and we're on this path up here, then we only have 3 cards left. And in those 3 cards, there's only 1 ace. So the second card we draw, if the first one is an ace, has only 1 chance in 3 of getting us an ace. So the actual chance of getting 2 aces is 1 in 6. If we apply the same reasoning, we get an ace and a king having 2 chances out of 3, and 2 aces, 1 in 6, and 2 kings, 1 in 6. For most people, this is quite counterintuitive. And it's a good little example to show that we're not wired in our minds to make good judgments about uncertainty and probability, even in relatively simple situations. Our mind's just not wired for it. And the key lesson that I'd like you to draw out of that is that when it comes to uncertainty, you want to use some formal methods to understand it. And what I find is I use my intuition to build back. Okay? At first I say, hey, this doesn't feel right, and then I go through it a couple times, and finally I align my intuition with what I've calculated, or the other way around in case I made a calculation mistake. But you have to kind of get to that point where you see it, oh yeah, now I get it. But it doesn't come naturally. So we also can do, now that we have probabilities, some mathematics about how good of a deal is this. Well, we calculate what we call the long-run average, or the probability-weighted average, and that is simple. We take 1/6 of 60, because 1/6 of the time, if it were done over and over again, we'd get 60. We take 2/3 of 30 and 1/6 of minus 18, and what we get is 10 plus 20 minus 3, or 27. So at this point, if we are here, the value of the game would be 27 to someone that we call risk neutral. That is, you're willing to play the average, the mathematical averages. That's because this loss and your investment isn't so big that you want to become risk averse. Okay? But some people show risk aversion even on relatively small investments. Now, if we invest $20 for a gain on the average of 27, we get a net value, or what we call the expected value. There's nothing expected about it, so we just call it the E-value most of the time. So the E-value of this is $7, and that can be calculated. And once we know it, it's pretty clear that what we want to do is invest. So the people that among you that said, okay, we want to invest, you were on the right track, if you're willing to play the averages in this game. Now it's time to resolve the uncertainty, so let me shuffle the cards. And go ahead, and you draw 2. Yeah, don't look at them, just put them down. Thank you. So now I have those 2 cards, and I'm looking at them. What's your probability that those 2 cards are 2 aces? You're saying 1 in 6 still because you know nothing more? Well, what do you think it is to me? It's obvious it's 100% or 0, right? Because I know. So how can we have 2 different probabilities about the same 2 cards at the same time? This was a philosophical issue for people for hundreds of years. And so many argued that the probability is in the cards, and to be able to make effective decisions, you have to realize that the probability is a language for us to think about uncertainty, and it's in our minds. It's not in the cards. And when we have different knowledge, we'll have different probabilities. To a businessman that makes decisions regularly, this seems like an obvious thing. And so much of statistics is based on frequency-based thinking that, in fact, denies this difference in judgment. So for us, we have to be able to express our judgment about uncertainty with probability. And that becomes a very powerful part of our tool. So in this case, what we got is an ace and a king. And with an ace and a king, you received an outcome of 30 plus. You invested 20, so you had a net gain of 10. And the outcome, in this case, was it wasn't the greatest outcome. But if you had lost and you had had a minus 18, would you still have made a good decision? Well, absolutely. You would have made a good decision, but you would have had a bad outcome. To be able to make good decisions, we have to separate decisions and outcomes and understand their difference. It's very fundamental. Now, accounting is the whole discipline of measuring outcomes, not measuring decisions. So the whole reporting system in most organizations reports on outcomes and results. Therefore, it's very hard to keep this clarity around the difference between decisions and outcomes in an organization. But for decision making, we must have that separation, because what we're all about is reaching high quality decisions, and that's the best we can do to get a significant fraction of good outcomes to the point of where the averages are working for us. And that is totally key. So in this demonstration so far, we've learned a lot of things already about sunk cost and decision making as being forward-looking. Uncertainty about the future can be expressed in possibilities and probabilities in a tree. We can have probability as an expression of our belief about uncertainties. It's in our heads, not in the cards. Our intuition is a poor processor of probabilities. Don't just trust your intuition when it comes to uncertainty. And the quality of a decision can be understood at the time you make it. You don't have to wait for the outcome. And the outcome is what happens. So a good decision can have a good or a bad outcome, and you don't then undo it. In fact, Ron Howard likes to say, a good decision never turns bad, and a bad decision never turns good. It's just that we might have a good or a bad outcome. And we can also calculate an indicator that we call the EV that gives us the value for a risk-neutral decision maker. Thank you, and we'll continue in another session.